Okay, KW. Now what's KW?
Just the ionization constant of water.
Okay. That's interesting. Given that KW for water, KW is equal to 2.4 times 10 to the negative 17th or 14th at 37 degrees Celsius. Compute the pH of a numerical aqueous solution at 37 Celsius. What is a normal human body temperature? Which is it the new? Okay. Okay, so I'm just gonna put in here 7.2. You know, all bodies are about 7.2 right now.
No, I don't think.
What is it? I think your body can't even your blood can't even function. It functions between 7.2 and 7.4. Like that's all it can fluctuate.
It's pretty easy to calculate it out.
And let's give you basics. There we go. Because you can't have anything acidic. Okay. Okay, so to calculate this out, the KW.
So this right here is the A of water, or of
Acid.
Acid, yeah. So it's just saying that instead of 1 times 10 to the negative 14th equals your H times your OH.
Sorry, say it again.
Okay, instead of this equals your H times your OH, that equals your H times your OH.
But I don't know my H or my OH.
But at a neutral, it says that it's neutral, so your H and your OH will be the same.
So 7?
No. So what it would be is so your KW equals, what is it?
2.4 times 10 to the negative 14th.
Okay, and that's equal to your H plus times your OH minus.
So I should take the square root of that?
Yeah, so that's the same thing, and it being neutral, those equal each other. So you got 2.4 times 10 to the negative 14th equals H plus squared. And so yeah, you can just square root that. That'll give you your H plus concentration.
So that'll give me 1 point. I don't know, I'm going to try and guess square root. I'll just write it.
pH will be negative log
Of the answer?
of your H plus, yeah.
There you are, square root. Come here. Pick a really small number. 1, 2, 3, 4, 5, 6. So 1, 2, 7. 1.55. I'm going to do this. Negative log of 1.55 gives me.
Was that times 10 to the negative 7?
Yeah. Okay. It's like the. That's not good. Okay. Okay. Okay, so it's negative 7, we're good. Okay, so negative log times 1.55 times 10 to the negative 7 gives me 6.8. Oh, my biology failed me. Given that water.
Yeah. Well, maybe blood is 7.2 because this is just saying for water. It's not saying for blood.
This is water in my body.
Yeah.
Water in my body is running around and slightly acidic.
I don't know.
Hold on a sec, let's think about that. That's true, because your cells are acidic on the inside. That way they can break down carbohydrates and stuff. I think, is that what it'd be referring to? Are we making connections?
I have no idea.
Is a pH equal to 7 solution acidic, basic, or neutral?
So it would be,
And the thing is,
if that's neutral, is that greater than or less than neutral?
it's less than.
No. If that's neutral, what would that be? So say that's 7,
Mm-hmm.
that would make that like 7.2, which would make it acidic or basic.
I guess basic.
Yeah.
Doesn't make sense. Okay, so let's start all over. Give that the kid for water at 37 degrees. Compute the pH of a neutral liquid solution, which is the normal human body temperature. Oh, this is just saying water in general, huh? Oh, so it's saying water for the most part is about 6.8 at 37 degrees.
Yeah.
Okay. Is a pH equal to 7 solution acidic, basic, or neutral at 37? I guess I don't get that.
So if at 37 degrees Celsius neutral is 6.8, then if you have something at 37 degrees that's 7,
That's gonna be more basic.
it's a little bit basic.
Okay. Okay.
So at 0 degrees, 7 would be neutral, and that would be like 7.02.
Okay. All right. Getting more in depth to This is 8 of 16A, and I am 1/3 through 1/4. 4 times 8 is 22, right? Yeah. Calculate the pH and POH of an aqueous solution that is 0.045 moles in hydrochloric at 0.0565. Is this an ice table now?
Mm-hmm. You don't need one. You will when you get to weak acids, but those are both strong acids.
Okay. Oh, duh, this is easy. It's just like that table we did, huh?
Yeah, kind of.
So these guys are gonna be mixed together.
Mm-hmm.
So then I start off by adding those two to the molecules.
Yep.
0.045 plus 0.065. So I have 0.01. So I have 0.11 moles of, this is hydronium, correct?
Mm-hmm.
Okay, going back to what I know, I'm just doing negative pH of that. 10 times a negative pH of 11
Wait,
gives me a syntax error.
you're trying to find the pH, and you have the concentration.
Now, here's a negative log then.
Yeah.
Holy cow, that's super acidic.
Yeah.
So mixing two acidic things becomes more acidic?
Oh, just you have tons of H pluses.
Oh, that's okay. That's more what's measuring, huh?
Yeah.
9 point. Let's call it 9.6. And this will be 13.04. 13.04. Good. And nice. Okay. Okay, so this is the same thing, another molarity. So I just gotta go negative log times 8.7 times 10 to the I did those correctly, right?
Yep.
So, that's interesting. When you have a small amount. Is that saying that's in an aqueous solution though? Or is that like saying like if I took a dropper and put down 8 times 10 to the negative 8th moles of hydrochloric acid, it only have a pH of 7.9? That makes sense? So like, is it like saying, here's hydrochloric acid, and if I took a little pipette and took out 8 times 10 to the negative 8th and then dropped it onto a little cup and then tested its pH? That can't be so.
No.
Because that pH, so that's saying like if I had an aqueous solution, right?
Yeah, and that's moles per liter. So you have a solution of 1 liter, and it has 8 times 10 to the negative 8th moles of HCl, which
Okay.
will dissociate, so it'll be moles of H plus and moles of Cl minus, which we don't care about the Cl minus. So you're just saying you have that many moles, that's 8, of H plus per liter of solution.
Okay, that makes sense. So,
Yeah. Because water's going to contribute, because since this is such a small number,
yeah.
compared to water will contribute more of the
Oh,
H plus
okay.
than will the HCl.
So-
you don't even really.
So I gotta go plus 1.1 times 10 to the negative 7th
Yeah.
and then compute that?
Mhm.
So for the most part, in any problem like that, if the number was 7 times 10 to the negative 8th, I'd still go plus 1 times 10 to the negative 7th?
Yeah, you'll always add that amount to anything because that's from water, but in most cases that's so small that it won't. Like in this case, this is so large, the concentration was so large that that wouldn't have affected it, but in this case it's so small that it does affect it.